Hello, my name is Andrew Carroll, and I am a staff member at the archaeological excavation of Poggio Civitate, Merlot, Italy, um, where I am also the current transit operator. And so today I'm going to be talking about the basics behind the transit and how you use it. Before I go on, I'd like to thank John Lannon, the site architect from a few years ago, who taught me how to use the transit, and then also Andrea Rodriguez, who put up with me as I frolicked off away from our trench to learn how to use this transit. So let's get into it. Transiting, where the numbers seem to be made up and the points really don't seem to matter. Well, that's not really true. While the numbers are made up in the sense they're not connected to latitude and longitude, and the points can be put anywhere, the transit is very helpful for creating a grid that allows for relative but quantifiable measurements. We can go a step further. By repeatedly using the same grid, we can then compare these measurements over a series of years. That is why in 1991 we established a master grid over the entire site. The transit is basically the child of a telescope and a compass. The telescope is used for taking sights along these different lines that we're measuring. The compass is useful for recording the degrees of these different lines. Now, because it is a telescope, you will need to have a clear line of sight. Our scope will magnify every little leaf that gets in the way. That's why it's helpful to have a good pair of clippers and also several partners who can walk along your proposed line and clear away any of the brush. Now, this is archaeology, not heart surgery. When using the transit, it's okay to have a difference of plus or minus 10 centimeters. That is still considered accurate. Remember, we are creating relative measurements here, not precision ones. If we're obviously operating on a heart, we would want precision ones, but here we can get away with these numbers being a little bit off. When you're using the transit, you want to make sure you write down everything you do. This includes the weather. For the heat of the sun can sometimes warp the sight lines that you're looking along and give you an off measurement. The people who are helping out on that particular day, so that you and or someone in the future can go back and maybe talk to them when you're not available. Relative objects that are around where you're working, so that people can come back and just using your notes figure out roughly where things were, so that they don't have to take the transit out. Make sure you record the points you've used, the measurements and calculations you've made, and the different points you've placed, and what the numbers, what trenches were established, so that in the future people can come back and either they will catch mistakes you've made, or they can just reconstruct what you did. Now, when you're using the transit, always double check that the knobs in the transit are locked when they're supposed to be and unlocked when they're supposed to be. Always double check the measurements that you end up taking and any calculations you've made. And it works well if you have an assistant to help you with all of this, so that you can make sure you're trying to be as accurate as possible. Now, some basics behind setting up the transit. You're going to want to first set up the tripod with a plumb bob attached. Now, you can see right here at where the mouse is, just the top of where the plumb bob is. The plumb bob is helpful for creating a more accurate measurement while you're centering the transit head over a known point. After you've set up the tripod, you will attach the transit head and then level it with these three black knobs that are down here. That's what I'm doing in this current photo. You don't need to crank on these knobs. Small adjustments work much better when trying to level out the transit head. And then after you've leveled the transit, you're going to want to line up the zeros with both the degree plate and the eyepiece that you will be able to see through here. That way, when you're starting your measurements, you'll know that the eyepiece is at the same degree as the degree plate. Now, when using any of the knobs that are on this transit, you want to be gentle with them. Many people have been using this transit over the years. The knobs and the screws have become worn, and so they can be loosened if you crank too hard on them. So you do want to be gentle with any aspect of this tool. Now, when you are creating a baseline, what you will start by doing is setting up the transit and leveling it over a known point. And you can see that here with this lovely stick figure drawing of a transit. Next, you're going to send a second person to a second known point with a rod to have them hold it perpendicular over that point. Then you line up the crosshairs in the eyepiece with the center of the rod, and now the transit head is on a known straight line. Hopefully this is one of the lines of our master grid on the site. You'll lock both the degree plate and eyepiece together and lock it to the tripod. And now you can leave the degree plate locked and unlock the eyepiece and spin it around. We typically turn it at right angles and use a tape measure to measure out more lines in our grid-like pattern. We could use trigonometry to create the baseline here. However, it ends up being more complicated and is not as easy in the field and not as foolproof in the field. This typically, using a baseline and creating it with right angles and tape measure allows for a more accurate creation. Remember, whenever you're using the transit, keep it simple. Don't try and make it more complicated than it has to be. The other thing that the transit can be used for is shooting datum. You'll set up the transit again, and this time where it's set up is not as important. Set up and level the transit and the eyepiece. And using a known point, measure the height of the transit to the center of the crosshairs. And then you add this height to the point's absolute elevation height. Now, our absolute elevation is based on an arbitrary point in the center of the hill, not really connected to contour lines or sea level measurements. However, in the future, if we wanted to, because they're all relative, we could take one of those points connected to a contour line, and then we would have the relative altitude of all the different artifacts and features we found on the hill based on that. But right now, it's just an arbitrary point unconnected from these different contour lines. Then all you have to do is swing the eyepiece around to a sturdy object into which you can place a nail, typically a tree. And then place a nail at the center of the crosshairs means that the nail is the same height as the transit and therefore also the same absolute height. And you can then either nail the nail into the tree or using a tape measure move it up or down to try and create an easier number to add and subtract for your datum. When dealing with datum, PC1, most of the known points on the hill have absolute elevations. PC1 and PC6 are the ones that we typically use when creating data. So some final comments. This video is just an introduction to how to use the transit. Nothing is going to beat field practice. You're going to have to get out there and you're going to have to work in the field with this instrument. All of this can be done with the total station, but you are a much better person for doing it the old-fashioned way, and you have a better appreciation for what the total station can do because you are doing the math that the total station does for you automatically. Remember to write everything down, even if you think you're overwriting. You're not. Write it all down so that way someone else can, if they need to, reconstruct your same thought process. Don't drop the transit. It's glass. It has a glass eyepiece. It's old. It will break easily. Be very gentle with it. And don't worry. We all screw up. Just fix it or ask for help when you figure out that you made a mistake. And nobody's going to be mad. It's worse for you to try and cover it up and hide that mistake than to go back and fix it. Like I said earlier, this is not heart surgery. No one's going to die. Just fess up and fix what you've gotten done. So hopefully this was a helpful video for you. Like I said, there's another video also on the master grid that you can watch on this same YouTube account. Thanks. Have a great day.